One misconception that I wanted to take a look at is whether or not people knew why the sky is blue. Previous examined misconceptions revealed that most people thought that the sky is blue because of somehow reflecting the ocean. And the ocean is blue, and so the sky is reflecting the ocean in some way. And I wanted to see whether or not this misconception would be held up when I interviewed other people.
You know, it's one of the big questions of life, I don't think we'll ever know.
That's something to do with gases in the atmosphere and the way they admit certain bands of the light spectrum.
Oh, I don't even know. I didn't know what to say.
Isn't it to do with something like the hydrogen particles in the air or something in the atmosphere and sunlight hitting it? And they'll cut like pretty colours everywhere. I'm not sure.
His God's favorite color is blue.
Because it's a reflection of the colour of the sea?
To do with
nitrogen.
Because something to do with the reflection of the water. Yeah.
I think it's the reflection of the sea.
Is it because ozone is blue?
Because the reflection of the sea.
As you can see from Science Nation, many people did have that misconception that it is some way connected to the reflection of the ocean. But there are other misconceptions as well as a small amount of fact in there. Now I'm going to ask my own interviewees why the sky is blue.
Okay, so why is the sky blue?
The sky is blue because Mama always told me that it's all the people smiling down on you when you're feeling down and out.
So do people perceive the color of the sky differently?
Of course they do. Everyone sees the color spectrum differently.
No, but seriously.
Okay, so why is the sky blue?
I always thought it had something to do with the sun and how the light reflects on Earth's surface.
And do different people see the color of the sky differently?
I would assume so, right? There's people that are colorblind and whatnot. And we both yes.
So Brad, why is the sky blue?
I think that the sky is blue because of the sunlight reflecting off of air particles or molecules, and it emits blue.
Does the sky look different to different people?
I suppose perception could have a play in that, but I also believe if someone were to be colorblind, then that would have an effect on it, so they in fact would possibly see the sky differently.
So why is the sky blue?
Well, I believe it's something to do with the light refracting off of the, it's the atmosphere and the clouds and the light bouncing off the clouds and bouncing back down to Earth, and it makes the illusion of a blue sky.
Do different people perceive the sky differently?
Do you mean the color of the
Yeah.
sky? I definitely think so, yes.
And what's that based on?
Have you seen the social media, the lace dress, the blue and tan, and it's just like that. Everybody's eye perceives color differently.
So why is the sky blue? Well, I'm going to let the folks at SciShow tell you why that is.
Why is the sky blue? Just give me a couple minutes and I'll let you know why. This is the world's most asked questions. The sky is blue because of three things: light from the sun, particles in our atmosphere, and the fact that you're a human. I'll get to that last part in just a minute. But let's start with how sunlight interacts with particles in the sky. I'm not talking about dust or water droplets or other big particles which are sometimes mistakenly used to explain why the sky is blue. Instead, it's the very small particles in our atmosphere that make the sky look blue. I'm talking about molecules in the air itself, mostly molecular oxygen and nitrogen, O2 and N2. These molecules are super abundant in our atmosphere and so small that they're even smaller than wavelengths of visible light. And that's the key. Visible light consists of a range or spectrum of different wavelengths. Light with the longest wavelengths are at the red end of the spectrum, and light with the shortest wavelengths are at the blue and violet end. Since the blue wavelengths of light are shorter, they're more likely to strike those tiny molecules of oxygen and nitrogen more often. And when they do, they get scattered in all directions. This effect is known as Rayleigh scattering because it was first described by John William Strutt, aka the third Baron Rayleigh, who in 1871 published his mathematical proof that blue wavelengths of light in the atmosphere are scattered 16 times more more than red wavelengths. But violet light has the shortest wavelength of all visible light, and it's scattered even more strongly by tiny particles. So why isn't the sky purple? Well, this is where being human comes into play. Our human eyes perceive the middle of the spectrum most sharply, which is why blue is way easier to see than violet. So even though violet light is being scattered around like crazy, we just don't detect it as well as we detect the blue. And that's why the violet band of the rainbow is often the hardest for us to make out. So SciShow viewers are in luck, because when we surveyed you, the most popular favorite color from the rainbow was blue. 33.55% of survey takers reported blue as their favorite color, while yellow was the least favorite at only 2.8%. Poor yellow. But there are other animals that can see all the way into the ultraviolet end of the spectrum, like honeybees and some birds. So maybe they like yellow.
What I walked away with after having completed this project and after having done the readings for this week is how difficult it is to change misconceptions, but probably that if we are going to tackle misconceptions as teachers, we have to do this through metacognition. Memory, all of the people that I interviewed were adults, so they had probably at one point learned and memorized different scientific concepts that should have helped them to understand why the sky was blue. They certainly, none of them struggled with attention as far as I know, and they were all focused on me during the interview. And obviously as adults, they are developed. Their cognitive strategies and abilities are more developed than, say, my students. But perhaps they have not actually reflected on their thinking about my question and whether or not that they really knew the answer or not. And that is sort of the important thing that I brought up in my post as well this week, is the importance of getting students to accept and be okay with saying, I don't know. And if they don't know the answers, not trying to construct some kind of answer based on something else that may or may not be right, maybe just taking a shot in the dark, because that could lead to a belief that could then become a misconception that could be really, really difficult to unlearn. And instead get students to, early on in the learning process, be okay with not knowing and be okay with needing to ask and figure out the answers. So that was the biggest implication that I found having done this project for my own teaching practice.